The year is 400 BC. There is this philosopher walking on the beach, and he sees the sand on the shore and thinks, wow, I'm going to take this theory to its greatest possible extent and think if you divide something enough times, you'll finally come to something that can't be divided anymore. And this philosopher is Democritus. Democritus coined the word atomos, which we know as atom, but atomos means undivided, which means something that can't be divided. He is the first person in our long timeline of people who contributed to the idea of atomic theory. But he was only a philosopher who made his philosophy before the invention of the scientific method. Therefore, it wasn't scientific per se. He only used logic to come up with this conclusion, which, oddly enough, he was right, for the most part. He did think that oil were just spheres that could slide right next to each other, which made it so slippery, and that iron were hooked things that gave it its strength, and that clay were ball and socket joint type things, which gave it its mobility. He was oddly wrong about all of those. Yeah. Genius philosopher. Don't give him too much crap. He was alive during 400 BC, which for his time was pretty advanced. Socrates thought there were 4 types of matter: air, water, earth, and fire. Yeah, air, water, earth, and fire. Which, for such a renowned philosopher, you'd think he'd know better. But they don't need to know better because it's 400 BC. Now. Skip 2,600 years into the future, and we come across a man, an Englishman, a Quaker, named John Dalton. John Dalton actually came up with 5 principles of what began what is truly known as atomic theory. So John Dalton's 5 theories were: 1. All matter is comprised of tiny, definite particles called atoms, similar to what Democritus thought. All atoms are the same substance and would have the same properties, meaning that they'd have the same mass, same volume, the same weight, all the same properties because they are the same material. Then 3, atoms are invisible and invincible, that they couldn't be separated into more parts, which he was wrong. There are electrons, protons, and neutrons. Then 4, chemical reactions happen when atoms are rearranged, which I guess he wasn't too far off on, but it's a simplistic way of thinking of it. So 5, atoms have whole number ratios when forming compounds. It's always going to be CO2, H2O, and the 2 is going to be there because it's the substance. After John Dalton came a man named J.J. Thomson, another Britishman who was a professor, and he came up with the idea that the atom is filled with a bunch of negatively charged things in it. And he called this model of the atom, which looks a little bit like this, the plum pudding model, because of a popular dessert they had in Britain. So he came up with this using a cathode ray, which was practically an electron beam going through a tube. And he discovered this when he got a magnet, put it on the negative side, it would come towards it, put it on the positive side, it would go away from it. Kind of like this motion when he put the magnet to it. So he came up to the conclusion that there are a bunch of negatively charged things within the atom. Then one of his students, Ernest Rutherford, did this experiment called the gold foil experiment, where he got gold foil and got that same particle, those alpha particles, to go and hit the foil, and he thought they would just go through the foil, right? Because if it's just negatively charged thingies, they'll just go through each other. He was wrong. When the ray hit the foil, parts started to bounce off of it, which meant that there was a proton, something positively charged, which was hitting it, and that there was a proton, something positively charged, which was hitting it and that the electrons wanted to go away from it. So Rutherford discovered something in the middle, a nucleus that is a proton. But some of the rays did go through it, so he also discovered that there is mostly open space inside the atom. Then, after Ernest Rutherford came Niels Bohr, which was also one of J.J. Thomson's students, and came up to the conclusion that electrons aren't just willy-nilly in there, but they have certain paths to follow. If they were just willy-nilly in there, positives attract, right? If there is a proton in the middle, the electrons would instantly go to it and everything would plummet as it exists. We wouldn't exist. So there had to be a ratio, or what's known as the planetary model, of electrons going around the atom or the nucleus of the atom. So this was Niels Bohr's discovery, that there had to be a specific orbit around the nucleus, which this is the model we mostly think about when we hear atom. Then came along a man named James Chadwick, who thought if there were positively charged particles in the nucleus, then why weren't they repelling from each other, right? Because opposites repel. Same things repel. And he came up with the conclusion that there had to be something else in the middle which prohibited this from happening. He discovered neutrons, which were neutral particles in the middle, which let the forces of the protons in the middle stay there without repelling, and made the atom stay together, essentially, because they would shoot apart when the protons came into contact with each other. Then a man named Heisenberg came along. Not that Heisenberg, I know what you're thinking. This Heisenberg was a mathematician who came up with the idea that the orbit around the nucleus of the atom couldn't be exact, because if it were exact, that would be mathematically impossible, and it would be mathematically impossible to calculate. So he came up with the idea of clouds or orbitals, which had probabilities of the electrons being there. They could be over here, they could be over here, they could be over here, but this orbital showed that it was most probable that it would be here, 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 etc. Atom.